Hi everybody. A few have asked me for another video so we can talk about games of incomplete information. Again, I apologize for poor video and audio quality. This is the best my laptop can muster. We'll just work with what we've got. Okay, so I'm going to walk through an example of a game of incomplete information. It's the same one from the slides, so you'll be able to follow along if maybe some of this is illegible for you. Just follow along on the slides. It's the same problem. Okay, so every game of incomplete information starts with a move from nature, right? This is Mother Nature. This is a coin toss. This is a random event that determines which game our players are playing. Okay, so in this sense, Mother Nature is deciding whether or not we're playing a game with a weak opposition, represented by probability P here, or if we're playing a game with a strong opposition, is represented by the probability 1 minus P. I definitely review the slides in probability theory if why we have P and 1 minus P doesn't make sense. Definitely go back and review those slides. Okay, so again, I'm just going to walk through all these notes here so we're all on the same page. That way you see what everything is, what we're going to be working with. Okay. So in essence, what we have here are two different games, two what we're calling sub-games that are being played in this overall game. Right? And remember, Mother Nature is deciding which game we're playing. Okay. We have two players, right? Mother Nature does not count as a player. We have two players. We have softliners. These are reformers. These are people who are introducing liberalization reforms in an authoritarian state. And we also have some opposition. Okay, these are people that the softliners might want to appease by liberalizing, right? Okay, so we have two players. We have softliners and we have the opposition. Softliners we can also think of as the state, as the government, right? Okay. The softliners have two options. They have two moves available to them. Okay? They can either do nothing or they can open up. By choosing to do nothing, they're maintaining the status quo, right? And by opening up, they're choosing to introduce some minor liberalization reforms. They're allowing some minor access to power for the opposition group. Okay? That's what we have in both of these sub-games here, right? It's the same set of choices. They can either do nothing or open up. Do nothing, open up. Okay? If the softliners do nothing, right, we have this payoff scheme. Right? Player 1 is the softliners because they're the first player to move. Right? So we can consider the softliners player 1 and we can consider the opposition player 2. Okay, so if the softliners choose to do nothing in a game where the opposition is strong, the do nothing softliners get 4 points. That's 4. And the opposition would get 3 points. It's the same payoff over here. Okay. No difference there. Okay. So if the softliners choose to do nothing, player 2, the opposition doesn't get to move. Right? There's no opportunity for them to act. But if the softliners choose to open up, the opposition gets to move. And the opposition has also two options available to them. They can enter into an agreement with the softliners. That means they accept what the softliners are proposing. They're accepting liberalization reforms, and that's it. Or they can choose to take advantage of the situation, excuse me, and organize, mobilize, push for democracy, push for more reforms. Okay? So if the opposition chooses to enter under a game where the opposition is strong, player 1, the softliners, get 5 points. Player 2, the opposition gets 4 points. It's the same payoffs for both games. Doesn't matter whether or not the opposition is weak or strong, the payoffs are the same for this game. Okay? And if the opposition chooses to agree to these reforms, the softliners don't have to do anything. They don't need to move again, so they don't. right? So the game ends there. But if the opposition chooses to mobilize, to organize, the softliners have a decision to make. They need to choose to either repress or democratize. I ran out of space here, so that just says democ, but democratize, right? Allow a transition. Okay? That's the same option available for both of these games here, okay? The only difference in payoffs between the two games comes in this final node here. If under a strong opposition game, the softliners choose to repress, the softliners get 1 point. Okay, it's still player one. We're looking at player one's payoffs here. And the opposition, player two, gets 2 points. But over here, if the opposition is weak, player one, softliners, the state gets 3 points, and player two gets 1 point. Okay. What this dotted line up here represents is uncertainty. The softliners do not know if the opposition is weak or if they're strong. They don't know. The opposition knows, right? You know if your movement is strong or if it's weak, right? That's why there's no dotted line here. Okay, dotted line's up here because player one has to deal with the uncertainty. So what we need to do, in essence, is figure out what player one's first move is going to be. Are they going to do nothing, or are they going to open up? Are they going to allow these liberalization reforms to take effect? Are they going to gamble on those reforms, thinking whether or not the opposition is going to organize against them if they do so? But in order to do that, we need to solve these games first, these sub-games. And we can do that using the process that we know very well, backwards induction. Okay? So what you want to do, step one, is to just solve each of these sub-games using backwards induction. That's step one. Okay? And we can do that. We know how to do that, right? You always start at the terminal node and you work backwards. In this case, we're working our way up the tree, right? So we start at the last node. We're going to start on this side of the tree. We're going to start at the last node, which is the softliners move. The softliners being player one, we're going to compare their payoffs. Player one's payoffs. So softliners can choose to repress or democratize. If they repress, they get a payoff of 3. If they democratize, they get a payoff of 2. Player 1 likes 3 more than they like 2, right? So we can prune this branch. We can get rid of it. And we can write our payoff. We can start writing our payoff scheme here. Because I have such limited board space, I'm going to shorthand this, right? So we know that player one's second move, right? It's their first move, this is their second move. Their second move, they're choosing to repress. So we can fill that in right there. I'm just going to write R for repress. Okay. So knowing that, the opposition needs to decide whether or not they're going to enter or whether they're going to organize. Okay. They know that if they do organize, the softliners here are going to repress them. So they would be stuck with a payoff of 1. If they choose to enter into an agreement with the opposition, they're going to get a payoff of 4. We're comparing player 2's payoffs here, 4 and 1. Right? They like 4 more than they like 1, so they're going to choose to enter into the agreement. I'm going to write E here for enter. There's player 2. Player 2 only has 1 node there, so that's all we can count for. Right? And we can prune that branch. So the softliners, knowing that if they were to open up, the opposition would agree they would enter into the agreement with the softliners. Okay, so the softliners in that case would get 5, and if they did nothing, softliners would get 4. They like 5 more than they like 4. They're going to open up, and we can prune that branch. Okay. I'm going to write O here for open. Okay? Great. You got that. Now we need to solve this game, this subgame. exact same method. Start at the terminal node and work our way back up. So softliners need to choose to repress or democratize. They're player 1, so we're comparing player 1's payoffs, 1 and 2. Player 1 likes 2 more than they like 1. They're going to choose to democratize, and we're going to prune that branch. I'm going to write those payoffs here. Let's see how I do with this limited board space here. So we have player 1's payoffs, player 2's payoffs. Okay. I'm going to write D for democratize here. Okay. So knowing that the softliners would democratize if they organized, player 2 needs to decide between entering and organizing. If they entered into the agreement, player 2 would get 4 points. If they organized, player 2 would get 5 points. They like 5 more than they like 4, so that branch gets pruned, and they're going to choose to organize. So we're going to write O here for organize. This is different than the O here for open. I'm going to write OR here for organize, just so it's clear. Okay. So, softliners, knowing that if they opened up, the opposition would organize and the softliners would have to democratize. The softliners have to choose between doing nothing and choosing this option, opening up, where if they did nothing, they get 4 points. And if they opened up, they get 2 points. They like 4 more than they like 2, so they're going to choose to do nothing, and that branch gets pruned. They're going to choose to do nothing. I'm going to write N here for nothing with a comma. Okay. We have those. Right. So now, what we need to decide to do, what we need to know, knowing these equilibria exist, we need to figure out which option the softliner is going to pick. Because look, if the opposition is weak, the softliners are going to open up. But if the opposition is strong, the softliners would be better off to do nothing. So which one do they pick? That's where our formula for expected payoffs comes in. Okay, so I'll walk through this formula here. I have EP, expected payoff. You'll also see EU for expected utility. This means the same thing. Is equal to the probability, PR, of event 1. I have a little subscript here of 1, showing that this is event 1, times the payoff for event 1. That's what that little 1 is, that little subscript for event 1, plus the probability of event 2 times the payoff of event 2. Okay? We always read left to right here, right? So whatever happens on this side, on the left-hand side, this is event 1. Whatever happens over here, this is event 2. Okay? So, again, at this stage, we're only concerned about player 1. We only care about what they're going to do. Are they going to do nothing, or are they going to open up? That's all we care about. Okay? So, we need to basically figure out the payoff, the expected payoff that they would get if they did nothing versus if they opened up. Okay? So, basically, this is just going to be a fill in this equation. Just plug in values into this equation, solve it, and you can get your expected payoffs. Okay? So I'll write that on this side here. So I like to work left to right, right? So I'm going to start with the do nothing option. So what's the expected payoff if the softliners choose to do nothing? Well, we're going to compare these payoffs, basically, or sort of aggregate them. Okay, so we're just going to plug these into this equation here. We have the expected probability, or sorry, not the expected probability, the expected payoff of choosing do nothing. Okay, in the slides here, there's a parentheses where it says choice, the expected payoff of a given choice. That's what this means. The expected payoff of, in this case, do nothing. Okay. So we know that the probability of having a weak opposition is P, right? This is where the payoff, this is where the probabilities come in. So we know that the opposition is going to be weak with probability p, and we know that the opposition is going to be strong with probability 1 minus p. So we know that, and you can write this either way. You could write this the payoff times the probability or the probability times the payoff, and you'll get the same answer. So I'm not too concerned about that. So you just want to start plugging in numbers here. So we're going to get a value of 4 for event 1 with probability p. Multiply that by p. Okay? That's event 1, right? Payoff of event 1 times the probability of getting event 1. Okay? We'll do the same thing here. So we're looking at this. This is event 2. The payoff of event 2 is 4. 4 times the probability of getting event 2 is 1 minus p. 1 minus p. Okay? Now we'll use some algebra here to distribute. Right? That is 4p plus 4 minus 4p. Okay? 4p minus 4p equals 0. Right? So those basically cancel each other out, and we're left with 4. That is the expected payoff of choosing do nothing. So if I were to ask you, what's the expected payoff of a given choice, that's what I'm expecting you to do. Okay? I'm going to erase that now because I'm literally out of space. So pause here if you need that part still. Okay. Okay. We're not done. We just now know the expected payoff of doing nothing. It's 4, right? That was what we just calculated. Now we need to know what the expected payoff is of if the softliners choose to open up. Okay, this is why we solved this game using backward induction earlier. Okay? So we're going to start on this side again. I like to work left to right. Basically, we need to figure out what payoff the softliners can expect if they choose to open up. So we're just going to be following down the branches here, starting at the top. Okay. So over here, if the softliners choose to open, we know that the opposition would choose to enter into the agreement. Right? We pruned this branch, so we know the path. We know which way the choice is going. So if they open up, the opposition is going to choose to enter. And player 1 gets a payoff of 5. Okay? So we can start plugging this into our equation. We know that player 1 is going to get 5 with probability p. Right? We're on this side, so everything is probability p here from this tree. Okay? That's event 1. Event 1 happens on this side of the tree. Event 2 happens on this side of the tree. Okay. Even though we pruned this branch, we need to figure out what's going on. What would happen if they did open up? Because that's what we care about for the second part, right? So if the softliners choose to open up, the opposition gets to choose to either enter or organize. We know, because we pruned this branch, that the opposition would organize. So follow that down. That brings us to another choice node here. The softliners choosing to repress or democratize. We know, because we solved this using backwards induction, that the softliners would democratize because we pruned this branch, right? So player 1 would get a payoff of 2 in that sense, okay? So they're going to get a payoff of 2 with probability 1 minus p. 1 minus p. I hope that's clear. So then we go ahead and start distributing and reducing, right? Distribute this 5, so we get 5p plus 2 minus 2p. Okay? We can simplify this a little bit. 5p minus 2p is 3p. plus 2. Okay? So if I were to ask something along the lines of what's player 1's expected payoff of choosing open, that would be your answer. 3p plus 2. Okay? But there is another step. There is one more thing we need to do, right? Because this still doesn't tell us which of these options player 1 is going to pick. We still don't know if they're going to choose to do nothing or if they're going to open up, right? So we know with our expected payoffs, remember this is the expected payoff if they choose to open up, and there's an expected payoff if they choose to do nothing. We solved that earlier. That was 4, right? So we know that they're going to only choose to do nothing. They're going to choose 4 only if that number is greater than this one, right? And this can be flipped, right? It depends on the kind of question you're asking, right? So, let's see, how do I say this? Yeah. Player 1 is going to choose to open with, and they're going to get this expected payoff. If they choose to do nothing, they're going to get this expected payoff. So they're going to choose this option, do nothing, only if they get more payoff by choosing this option, right? And you can say this vice versa. They'll only choose this option if the expected payoff is greater than this option. It can be both ways, right? Don't worry so much about that on the exam. I'm not going to have a tricky one where the sign is facing one way or the other way. That's not going to be on the test, so don't have to worry about that. All the signs will be facing the same way, so you don't have to stress about that. Okay. So we can basically treat this inequality sign as an equal sign. So we can do some math here. We can try to isolate p. That's what we're trying to do in essence. So we'll go ahead and subtract 2 from both sides. We're going to be left with 3p greater than 2. To isolate p further, we'll just divide by 3, and we'll have p greater than 2/3. So what this says is that they are going to choose this option, this is the open up option, only if the probability that they get a weak opposition is greater than 2/3. Basically, this means they need to be more than 2/3 certain that their opposition is weak, and then they would choose to open up. So, if I were to ask for the circumstance under which player 1 would choose to do one of these things over the other, this is the answer I would be looking for. Okay, I hope that's helpful. I hope that's clear. Happy studying.